Which one you got? Which one you got?
You only going to 5?
All three.
12. Which one?
Number E.
That's 12.
Number E. Number E, dog.
You know
Number E.
That's X3, parentheses 4.
The answer is
And the answer is X12.
Alright. Alright. So that's everything. Who got G? You want the G?
F is 2.
It's 2X12, girl.
Why y'all writing the problem if the problem right there?
What's G? Okay.
Hey, nah, your head big as a mug, cuz. I ain't even gonna hold it. You're in the way, cuz.
It's still there. It's going to be on there.
Alright. Okay, so ladies and gentlemen, everybody does everybody have all of these answers?
Nah, not yet.
Did everybody get the same thing for all of these answers?
Yeah.
You did?
Yes.
Alright, so ladies and gentlemen, let me tell you something.
One on wrong. Nah, don't erase E and F and G.
F and G are incorrect. Alright?
You got it, because you got to do it by everything.
You gotta do the little X though. I know what I'm talking about. You gotta do this. You gotta do that.
So, alright, so the question is, what does the parentheses mean?
See, now it's when they all stupid. Now it's when they all stupid.
Hey guys, Ray Sean. So say it again, Saquon, what does the parentheses mean? So everything inside is affected by our exponent.
It's going to be 3.
Right, so remember, everything is affected by our exponent. So the rule or the law of exponents says that whatever the exponents inside the parentheses are multiplied times the exponent that's outside. So why would we multiply or put an exponent with 2? Because what's happening here at 2? 2 has an exponent of 1. So we're multiplying all our exponents. So 2 times 4 times 1 and 4 times 3. So we're going to get 2 to the 4th power, x to the 12th power. And then if we evaluate this, what do we get? What's 2 to the 4th power?
That's F?
Yes.
2 to the 4th power would be 2, 4, 6, 8, 8.
No.
16.
16, not 16.
16x to the 12th power.
16.
Alright?
Not 16.
So therefore, so what is it going to be for G? What is it going to be for G?
It's going to be, it's going to be 15.
No.
It's going to be,
I
know, yeah. That's going to be 3 to the 5th power.
There you go, so 3 to the 5th power.
It's going to
be X to the 10.
X to the 10.
X to the 10.
So now,
It's going to be 65.
what is 3 to the 6th power? Evaluate it. Use the calculator.
20?
Nah, that's the power is multiplying. So you'll be multiplying 3 times 3 times 3 times 3 times 3.
243.
243. So it's going to be 243.
X to the 10.
243 x to the 10th power. We're still talking about graphing exponential growth functions. Alright? But we're going to look at how just changing some things in our exponents or in our function itself changes our graph or changes our graph, our values in our table. So that's pretty much what we're looking at today. So we're going to be doing a lot of drawing of graphs today. We also going to be using the calculator a lot today to draw those graphs. So we're going to go through a little tutorial for the calculator again.
The more practical and powerful they become, such is the case in equations called exponential functions, where the x, you've probably never seen these before, where the x is in the exponent. Let's take a look at something like this. Very simple one, y equals 2 to the x. Let's look at the graph and all the possibilities of plugging in various x values into this function. Once again, let me tell you that since the x is in the exponent, we're going to call it an exponential function. Now let's see, for instance, if we plug in a 1, y will equal 2 to the 1th, right? Or 2. The point 1, 2 is right there. If we put in a 2, y will equal 2 to the 2th, or 4. And you're thinking maybe this is a linear or linear function. But let's put in a couple more points. 2 to the 3rd starts getting much bigger, quicker, is 8. Starting to bend a little bit on you. 2 to the 4th is 16. So we look at the point 4, 16. It's getting very high very quickly, isn't it?
Yeah.
Let's go the other way. If we put in a 0, 2 to the 0 power, remember about exponents. Anything to the 0 power is 1. Okay, so we have the point 0, 1. What if we put in negatives? 2 to the minus 1 power. Remember, that's not a negative number. 2 to the minus 1 power is the reciprocal. That's what the negative does. So it's 1 over 2 to the 1th, or 1/2. So let's look at the point back 1, or negative 1, and up 1/2. Put in a couple more. Negative 2 is also going to give us a non-negative number. It's just going to be a smaller number. It's 1 over 2 to the 2th, or 1/4. So we go back 2 and up a teeny bit, a 4th. We put in one more, put in negative 3. Do you know what we're going to get? We're going to get 1 over 8, 1 over 2 to the 3rd. Notice that it's never going to get negative, is it? It's just going to get very, very small. On the right side, it'll go to infinity. And the left side, it'll get teeny, teeny, but it'll never really reach 0. Now that line that it will never reach, we have a name for it. Since in this case anyway, it can never be negative because it can never reach 0, we have a name called an asymptote, sorry about that, an asymptote, when it never quite reaches it. And that's worthy of remembering because that's going to happen all the time in these exponential functions. Now don't be confused about this never negative idea. For instance, if we look at the same function, but let's add a negative 3 on the end of it, that's where y equals 2 to the x. If we look at what y equals 2 to the x minus 3 is, what's that going to do to the graph of the function? Well, it's going to lower it 3, isn't it? So we'll still have an asymptote, and some of these values will be negative, okay? It just will be in a lower place. Okay, but the point is, with these exponentials, it's going to have an asymptote somewhere where it will never really reach the value, will never really reach that line. Interestingly enough, what if we change the location of the negative 3 or minus 3? Let's try putting it in the exponent itself. Well, you know what will happen then? We'll get the same numbers, except it's going to actually be moved to the right. So I take y equals 2 to the x, and I'm going to move these values down 3, actually, and put in some much smaller values, actually. And the graph will still move over, but it'll still have an asymptote, okay? Well, what what if we looked at an exponential function where the exponent x is a negative number? The new function with the negative exponent is going to look the same as the normal function, except it's going to be a mirror of the normal exponential graph about the y-axis. Something like this. Notice, it will still have an asymptote, a number that it will never reach. And these two functions occur very often in real life. The one, the normal if you would, y equals 2 to the x, we call exponential growth. Okay, many things, living things, and hopefully your money, grow exponentially. They don't grow linearly. Okay? And if they get smaller, we call it exponential decay. Sometimes, hopefully your money doesn't get smaller exponentially, but often many living things, colonies or whatever, get smaller exponentially as well. Okay? So be looking for these in many of the word problems we'll be looking at.
All right, so ladies and gentlemen, so what did you learn from that video? You didn't learn anything from the video?
That when you have,
What is negative?
that when it's negative, it will never hit.
Excuse me.
And what is that line that would have never hit? What is that line called?
The X is, I mean, the X.
I got a question.
No, the X axis.
No? What is that? What is that? What is that? Huh?
Parabolic.
No,
I got a
you
question.
hear
So, Microsoft Exchange or something like that?
Microsoft Exchange?
You gotta use some on Microsoft to deal with exponential growth.
No, well, you know.
I know I'm talking about.
What are
I
you
did
talking
this before,
about?
but I did this before.
Okay, so you can use, because Microsoft is a tool, right? It's a tool that you can use to, you know, show exponential growth, because you could do graphs and different things on there. But it's not, you know, for exponential growth per se. It's something that you can use to do
When
it.
I did this, I forgot which school I did this in, but that's what we had to use.
Okay, yeah. But you had to put in your data, right? But you had to put in data for it.
Yeah.
Yeah, so yeah, you could use it, because you could use Excel. You could use Excel as a tool to do it, yeah. So, but what they were talking about is exponential growth is, you know, I don't know if we talked about it the other day when we spoke about like bacteria and different things like that. So he said living things, that's how living things grow. Living things grow exponentially. You know, so cells, bacteria, all those things. What else was said in that video that you could come up with?
About the negative exponent.
All right, negative exponent. If you have a negative exponent, what happens to your graph?
It mirrors.
It mirrors, right? So that's one. What happens if we add a number to our exponent, to our function? But it increases or decreases which way? Up and down. So yeah, so those are some of the things that you see. If you put it in the exponential, if you put it in the exponent itself, it moves left to right. So here's a little bit of notes for you guys. So here you go. So what happens when I change some things up in my exponential function? Here's our exponential function. It can be written as b x minus h plus k. So when we make changes to h, ladies and gentlemen, when we make changes to h, it moves the graph left to right. So we move left to right. If it makes changes to k, it moves it up or down.
Up.
Right? So that's what you're going to see a lot of when you do your graphs coming up. It's either going to move left to right, or it's going to move up or down. For h? No, it doesn't matter what number you put in there. That's how far, that's how you'll move it. So you'll move it 2. So if you add 2, right? If you add 2, it'll move it to your left. If you subtract 2, it'll move it to your right. So it will open up more. If it's an addition, it will close it up more. It depends on your function. So you can put in anything. Your function. if I have 3 here and then X minus 4. I'll give you that. Put in your table also. So you're gonna put in your table. Remember your table will have 3 values. One for Y1, one for Y2, one for Y3. Alright? And we'll be coming around to make sure that you're on the right track. So those are the 4 graphs that you're plotting now.
What's that on your graph?
Any questions?
Yeah.
Yeah, that's what you're doing first, graphing on the calculator and then moving forward.
Yeah.
So what happens? When it, so look at what happens. So what you have to describe is what's happening. What happens when you multiply by 2? So like the first one, if you have 3x, that's your base graph. Then when you multiply by 2, what happened to it? What happened to the graph when you multiply by 2? Anybody see it? What happened when we multiply by 2? And then what happened when we multiply by a quarter? So that's what you have to describe. So which direction did it go?
It went up, vertical, horizon.
Yeah, it went vertical, but which direction did it go? Depending on how the size of what it's multiplied by. Alright, so what the problem is here is that you're not putting it in the exponent. These are, because what are these? These are linear.
What I have right here, a box of
Why are you getting a line? Why are you getting a straight line? Why are you getting a straight line? Linear. Yeah, but you know why you're getting a straight line? Go back to your line.
Oh, you stepped over with your phone. You ain't gotta see them again.
So it's supposed to be 2 to the what? So last time you just had it as you just had it as 2x. So you didn't put it as an x.
Watch it.
Okay, so my question to you is, why are we getting a line, a linear function? Why is there a line there?
Right here?
No, on your graph. Why is that line there?
Because that's what that equals.
Yeah, but what is that supposed to be 3x? What is it supposed to be?
It's supposed to be 3
3 to the
3 to the first power, I guess.
3 to the x power, right? So you're gonna have to make it what do you call it?
But
Exponent.
I tried to do that, but it wouldn't. So you would do that as a regular exponent. It would be
Right.
1.
No, you use this, right? Remember?
That's what I did. Every time I did this, it went like that.
Right. That's what. So it works for the second one, right? But does it work for the first one? You know, this is the first one set of graphs that we did.
Oh, okay. And then at 3 o'clock,
Shakayla Park's work complete. I'm on the move to B. A is done. Hey, good job.
This is repeating this thing.
It's supposed to be, I'm supposed to hit the second.
she's on the camera.
You already said it, John.
You want to take it? I would take it.
The graph.
That's an oh, you did a fraction.
You got to put in the calculator. Oh, my bad.
Who was that? That was
Can I get some water?
Yeah. Now, let me grab my name. Chloe, you need to grab my name.